problem 18, and I do mean the first problem 18 on the review. Like I said, teachers are almost perfect, but they make mistakes. So, a cylindrical canister holds 3 tennis balls. Assume the diameter of the tennis ball is the same as the diameter of the cylinder, so it's close enough, right? 6 centimeters. So the diameter equals 6 centimeters. And that the tennis balls come up right to the top of the cylinder. All right. So the tennis balls, there they are, right there. Now, what is the total volume of tennis balls? So if I was trying to find the volume of the tennis ball, I need to know, look at my math chart. They're spheres. So I go to the volume section of my math chart and I look at sphere, come straight across, 4/3 pi r cubed. Volume equals 4/3 pi r cubed. Okay, pi's on my calculator, 4, 3, those are buttons. I just need to figure out what the radius is. Well, the radius is half the diameter. So, radius equals 3 centimeters. Just substituting in my calculator. Oh, and this is only for one sphere. How many tennis balls are there? I have to do 3 times that. So, the volume of the tennis balls is 3 times 4/3 pi times 3 cubed. Wow, that's a lot of 3's. These 2 3's simplify. So it's just 4 times pi times 3 cubed. Using your calculator, 3 cubed is 27. Okay, if you forgot how to do that, I'll do it again. Using the easy way, 3 caret 3. Enter. And you get 27. Now I'm going to go ahead and multiply that by 4 because I don't have a lot of room. And I get 108. 108 pi is the volume of the tennis balls. All right? What is the surface area of just one of the tennis balls? So I get my handy math chart again. Make sure I go to surface area, sphere. There's only one formula, 4 pi r squared. So S equals 4 pi r squared. So it's 4 times pi times 3 squared. So I get 4 times pi times 9, or 36 pi. And that will be centimeters squared. Since that's surface area, this really is centimeters cubed. I left my units off. Naughty teacher. All right, since we were still, this one's problem 18, might as well continue on with the second problem 18. Oh, by the way, I had a student ask me a question about this problem. She says, what if I had to find the volume in between? Because we did a warm-up in class that had one ball in the cylinder. So the way you would do it is you take, my favorite way to illustrate this is if I were to have water in this cylinder, right? And I push the balls in, what would happen to the water if the cylinder was initially full of water? The water would spill out. And in fact, just enough water as these 3 balls take, that's how much water would spill out. So you'd want to do the volume of the cylinder minus the volume of the 3 balls put together. Okay? All right. Problem 18. And thank you, Anna, for asking me that question. Mr. Patterson has a fish tank in the lobby of his restaurant. It is 3 feet long, 1.5 feet wide, and 2 feet high. He wants to double each dimension. Ooh, love these problems, all right? Because all 3 dimensions are changing, life is good, all right? How many times larger is the volume of the new fish tank? So he is doubling. My factor is 2, all right? If I asked you how wide around, I would say, for perimeter, I'd say times 2. My old perimeter times 2. For area, I would say area times 2 squared. Where does the square come from? It's 2 dimensions for the area. You have 2 sides that are really being doubled and affecting that. All right? If I'm talking about volume, volume is 3-dimensional, so that's times 2 cubed. So you'd multiply it by 8. So it didn't ask about these others, but I wanted to just take this chance to go ahead and review how the factor happens when you're doing all 3 dimensions. It's a super easy problem. You just need to look at how many dimensions are and what you're trying to find. If it's perimeter, it's 1 dimension. Area, 2 dimensions. Think square area. And volume is 3 dimensions, which makes sense. Cubic units, cubed.